Hello class, this is Mr. McAllen again, and what I want to do today is I want to discuss the importance of convergence, and I have a couple examples, and then I want to talk about the convergence theorem, and that'll be all the time I have for this short video. So what I plan on doing is I want to examine an example, and we're gonna go back and we're gonna look at the geometric series 1 over 1 minus x. And we did this in one of our earlier examples, and we know that this is equal to the Taylor series of 1 plus x squared plus x cubed plus, and we get out to our nth term, and then we'll finally get out to what our series will be, our infinite series will be. We'll go from 0 to an infinite number of terms for x to the n. So what we'd like to do is we'd like to figure out under what conditions this series would converge. As we mentioned earlier, because it's a geometric series, we said that the conditions for convergence would have to be that the x value is between -1 and 1. And what does it mean as far as convergence? Well, it means that this function on this side, on the left, will equal identically the function on the right, the polynomial, as long as these convergence conditions are met, where the value of x is between 1 and -1. Outside of that, the function won't equal the polynomial, and this series will be pointless to use. So let's take a look at what happens if we graph both using the graphing calculator. So I have the graphing calculator, and what I'm going to do is I'm going to put in the function 1 over 1 minus x. And I'm going to put in the polynomial, and that will be actually, I'm going to zoom in a little bit closer. I'll just use a better zoom window. And I'm going to put in to that function also, I'm going to use the polynomial and see how close it fits. So the first function will be the line, well, if I use just the line y equals 1, the first term, you can see that I match at a point. If I go back and I change that to where I use the first two terms, you can see that I'm fitting a bit better. I'll add another term, and you'll see that I have an even better fit. And as I keep increasing the number of terms, it looks as if the fit gets better and better. So I'll do x cubed, and I'll add x to the fourth, and we'll just examine how good the fit is. And if you look at the window closely, you'll see that within the domain of 1 and -1, I have between 1 and -1, I have a pretty good fit. And then right here it starts to break away. So as long as I keep the x value between 1 and -1, it appears that I have convergence. If I have if the x value exceeds 1 or -1, the function will diverge. And all that means is that my function will not equal my infinite series. So we really want to find the conditions for which the function will equal the infinite series of polynomials. So this leads us to our next point on the objective as far as what the convergence theorem actually is. And what the convergence theorem actually is it gives us it tells us the three things that can happen when we're checking for convergence. The first thing, well, let's just write down our general form for a series, and that would be the sum of an infinite number of terms starting from 0 going to infinity, and this is just the general form for a power series. Okay, and what this basically would represent is it would represent our function, and the things that can happen are as follows. The first thing is the series converges only at a point. And it diverges everywhere else. This would mean that the radius of convergence is equal to 0. The second thing is the series converges for all x, and that would mean that our radius of convergence is infinite in value. That simply means that no matter what value of x we use, the polynomial will equal the function. We just need to have enough terms in the polynomial to make sure that it converges. And the last thing is that we have a radius of convergence, and that would be R is a radius of convergence such that x minus a, the term inside the polynomial, as long as it's below the radius of convergence, we're going to have the polynomial equal the function. And the way this notation is written out, if you remember from some notation that we did, is that if we center, based on the absolute value, if we center our polynomial at the value x equals a, the way this is written is that we have a radius to the left and to the right for which the function will converge. So this at this point here would be at x equals a plus the radius, and over here we'd be at x equals a minus the radius. So these are the three possibilities for our power series. And this concludes this part of the lesson, but then in the next video what we're going to talk about is we're going to talk about a test for divergence, and we're going to look at a direct comparison test. So I hope you tune in to check out that video. I hope this helps, and we'll talk to you later.